This is the first page of our notes that we're doing for standards NS6 and NS8, and you'll have a copy of this that I want you to write on with me. So we're talking about graphing on the coordinate plane and on the number line. And I apologize, my paper got wet, so that's why it looks like that. You're going to have to do this on your assignment as well. These are number 1 and 7 exactly from your assignment, so we're going to use those to help us. So we're talking about how number lines, they can be used to show numbers and their opposites. So both 3 and -3 are both 3 units from 0 on a number line. Graphing points and reflecting across 0 on a number line extends to graphing and reflecting points on your x-axis, which is your horizontal number line, and your y-axis on a vertical number line, and how those can also represent a coordinate plane. So we're going to talk about that here. So number 1, we're just going to jump right in for some examples. On the horizontal number line, they want you to plot 7 and -7. So if you look here, here's horizontal, plotting 7 would be right here, -7 would be right there. Plot 7 and -7. Once you've done that, look at your dots. Did you plot them? Check, check. What is the distance of each point from 0? Each one would be 7 units from 0. So each is 7 units from 0. This one's 7 from 0, and this one's 7 from 0. What is the distance between 7 and -7? So that's starting from here all the way to here. Well, this one is 7 away from 0, and this one's also 7 away from 0. So they're actually, the distance between 7 and -7 would be 14 units. How do I get 14? They're both 7 away from 0, so together that's 14. So how does an absolute value write a number sentence to help us find that distance? We're actually taking the absolute value of -7 and we're adding that to the absolute value of +7, which is really just saying 7 plus 7 equals 14 units. So there's multiple questions that you have to answer here. The first one's plotting. Then the next one's asking how far is each point from 0. And then it asks you how far is the distance between the 2 points. And then how does a number sentence help you. So here's your number sentence that you write. It helps you answer that. The next one goes, instead of number lines, we're talking about graphing. So the points 1, 3, which means over 1, up 3, that's the star. -1 and 5 is our triangle. -3 up 3 is the smiley face. And then 4, -4 is the lightning bolt. And they have been graphed on the coordinate plane over here. And we have to reflect each point across the x-axis. So reflect each point across the x-axis. So you have to know x is this one here. This is your x-axis. So if they are above them currently, when you reflect them, they'll be below. If they're below, then when you reflect them, they'll be above. And so what are the coordinates of the reflected points? So when the star is reflected, see how it's 1, 2, 3 above? It's actually going to be 1, 2, 3 below. So your star is going to be here. So its new coordinates would be 1 and then -3. The triangle, which was at -1, 5, in other words, it's 5 above, it's now going to be 5 below, and it's actually going to be pointing down when it reflects. So that is -1, -5 for its new coordinates. The smiley face, -3 up 3, so it's 3 away right now, it's going to be 3 below. And the smiley face would actually be upside down when it reflects. So that would be -3, -3 for its coordinates. So the 3 that were above are now below, and the lightning bolt that's below is now going to be above. So over 4, down 4, but now it's going to be up 4. 1, 2, 3, 4, up 4, and so now it's going up. So over 4, up 4. So what do you notice about the original coordinates and then the new coordinates? That's what they're asking, the similarities between the coordinates of the original point and then the reflected point. And so what you're going to notice is 1 comma 3, x, y. 1, 3 becomes 1, negative 3. Negative 1, 5 becomes negative 1, negative 5. Negative 3, 3 becomes negative 3, negative 3. So it's like the first one is always the same. Your x is always the same, but then your y coordinate becomes its opposite. So since you're reflecting across the x-axis, it's still the same distance over, but the up or down changes. So your y coordinate becomes the opposite. So when it's reflected over the x-axis, your x coordinate stays the same, but your y coordinate becomes the opposite. So instead of like up 3, it was down 3. It becomes the opposite. So when you look at the old compared to the new of each one, they're really similar. The first one's always the same, and the second one is its opposite.